dog?
I counted up all of my coins till I had $300 to get a new dog. And my mom said, we're not getting it. She's like, no, we're not getting it. I said, I'll pay $300 to get the dog.
Yeah, I don't know if your parents would be. That's nice.
I literally counted up $300 for coins. And then she said, no, we're not getting it. But you got one. No, like, yes.
Alright, so we're doing the template. I gotta remember that because I like mix them up every time we're gonna use the template, do the template, so you should use the other sheet, the one you just wrote on.
Oh, I can't. I use the back sheet.
So we're gonna do a 2 sample Z interval, or you could call it a 1 or a 2 prop Z interval, like 2 proportions. But this is what your calculator calls it. So I'll change this over here to that. It doesn't make a difference. Wait, that's not the right. No, hold on. I'm looking at the wrong thing. It is 2 props Z interval. Don't call it that. Hey, go get another template. Go get another sheet. 2 props Z interval. Sorry. Or right, yeah. Well, I forgot what the calculator calls it. So they do call it prop for proportional. Alright, so this is the whole, like this is all the confidence intervals we're going to run through. We have done these 2, like that's what you just took a test on. If you have 1 proportion or if you have 1 sample and we're looking at the means. Now we're going to look at what if we have 2 proportions and I want to estimate the difference between them. And then what's coming next week is what if I have 2 samples and I want to estimate the difference between the 2 means. But right now we're doing proportions. So like the problem I put up there, a certain percentage of people were college ready in SAT in this year, a certain percentage were college ready this year. So there's a difference there, right? Let's estimate what the real difference is. But in the populations, like these are just 2 samples. So this isn't, like this has kind of a confidence interval to it. Because I can't just say like that percentage applies to the population. It's kind of got a window. And so does this one, and then I'm going to subtract them and get a window for the difference. So I want to be able to look at and say, I think the difference between these is between 3% and 7%. Or like 0.03 and 0.07 it would be. The process stays the exact same. The conditions stay the same. What changes is your statistic is not just p hat now, because now you have 2 p hats. You got p hat 1 and p hat 2. So your statistic is the difference between them. Z star is still Z star. And then notice this formula is basically just copied. Like there's just 2 of them now, because you have 1 sample here and you have 1 sample here. N does not have to be the same. It's the same in this problem, but I kind of regret doing that. I wish I should have made a difference to give an example, but we'll have a bunch of those. And your conditions stay the same. The only thing that changes is randomness is just now for both. Independence now has to be for both, and normality has to be for both. So this is what I was talking about. Like, there's not a bunch of new stuff in this chapter. All we're going to do is this and this, but it's really just built on the exact same stuff. So let's do the template. So now, instead of saying P equals the population proportion, whatever, we have to say P1 equals true population proportion, blah, 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 context. And P2 equals true population proportion, blah, 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 context. So you've got 2 proportions now. And that's how you tell the difference. Like, am I supposed to use a 1 prop or a 2 prop? Well, how many sets of data do you have? You have 1 set or 2 sets. And then estimate the difference, and be careful here, because you could do this either way. You could decide I'm going to do P1 minus P2. The person next to you might decide they're going to do P2 minus P1. They're both okay. It doesn't matter which way you do it. Like yours might come out to 3 to 5, and theirs might come out to negative 3 to negative 5. Because if you switch the order of subtraction, it just changes the signs, you know? But they're both correct, so you could do it either way. I'm always, not always, I guess, I shouldn't say that, but I almost always try to do P1 minus P2 just to keep it consistent, so it's always the same order. But even then, you might have called your P1 something different than I called my P1, so we could end up flip-flops pretty easily, but that's okay. We want to estimate the difference, but you need to tell them which one you're doing. That's the main thing. So I'm doing P1 minus P2 at a 95% confidence level. Didn't I just say we're doing the template?
Yeah.
Freaking do this every time. What would you like me to do at this point?
It's still fine.
It's still a template. The only number you put is 95.
Oh, that's true, yeah. Okay. Blank percent confidence level, yeah. Alright. Okay, conditions. So it's the same stuff. It's R-I-T or R-I-N? Rid. But it's just got to be for both now. So randomness. So you have to say something like both samples are stated as random. Bless you. Independence is a little bit of a different deal. So we've got these two samples, right? What has to be true is all the people in this sample have to be independent from each other. All the people in this sample have to be independent from each other. And this sample has to be independent from this sample. So you got three things. So I'm going to write independence. So I'm going to say each sample independent from each other. And each, blank, independent within each sample. So for the example we're thinking, I would say, each student in 2017 was independent, each student in 2018 was independent, and 2017 and 2018 are independent. So you got three, this one's independent, this one's independent, and these two independent from each other. It's kind of big. The next one's also big. So N is for what? Normality. Well, now you've got N1 P1 has to be greater than or equal to 10. N1 Q1 has to be greater than or equal to 10. And what else? N2 P2 greater than or equal to 10. N2 Q2 greater than or equal to 10. So it doubles your work in the conditions because you have to do everything twice. But after that, it's not bad. That's the hard part. That's the hardest part of the new stuff. You don't like it? Yeah. I don't know what to say.
That's cute.
I heard about your drone video 15 times yesterday. Yeah. People kept saying, did you know someone flew a drone? I was like,
No, it was just flying around.
Yeah,
for a minute, and
no, they didn't know it was in my classroom.
I
you see
was
video of
watching
your
other
own.
people's stories, and you could see me videotape too, and I was like,
yeah, I was videotaping it. I could see 6 people in the background.
Yeah. Alright, what's the first thing that goes in the math box?
The words.
Words. Same exact words. Statistic, plus or minus critical value. Times standard deviation of statistic. No, that's something else.
Yeah.
No, it's a formula sheet. What?
Have you ever ended up candy in this class? Yeah, just give up gum, I guess.
I don't know if I used to give out Davis dollars for extra credit. I have a picture of my face on it. It's pretty funny.
You use them.
Extra credit. But then there's like a black market for them, but people started selling them. So got a little out of control. Okay. Statistic is now, we have two samples. We want the difference between them. So it's not just P. The statistic is what's the difference in our sample proportion. So the statistic is now P1 hat minus P2 hat. It needs to be in the order that you wrote this up here. So keep it consistent. It doesn't matter which order you do. You just have to keep it consistent through the problem. Plus or minus, your critical value is a T star or Z star? Z star what? We're proportions. And then you will not have to memorize this formula. It's not that bad, but this is the formula sheet that you guys get. Have we looked at this yet or not?
No.
Okay. So if you look at just a couple things. Right here, we put Sx bar over the square root of n. Mine's technically more correct. This is more like a general usage. So just kind of realize when they say that the standard deviation of a sample mean, just think about it as the standard deviation of my square root of n. It's technically the standard deviation of the sample, but they put the sigma there so they can use it as like a big picture thing. And then the other thing that I do, that I guess the formula sheet doesn't, I think it's a lot easier, but if you want me to switch, I'll switch. I put PQ instead of P times 1 minus P. Is that easy enough to realize those are the same thing?
Yeah.
Okay. So if you look down in the next one, so this right here is always there. That's what we write at the top of every one, right? Like that's our words in the math box. And then we want the standard deviation of the statistic, and we have the difference of sample proportions, right? Don't use this special case one. There's no need to ever get into that because it only works in the special case, whereas this one works every single time. So when the proportions are the same. But I'd rather just learn the one that works every, you know what I mean? It's just easier to always use this one. And again, I would call this P1, Q1, but if you want to do the 1 minus P, that's the same. But you will not need to memorize this formula. It is on the formula sheet. You get this, it'll be on the board. The standard deviation of the statistic is, I mean, last time it was PQ over N, right? Well, now it's just P1, N1, Q1, N1. You're just doing it twice.
You can still call it Q on the test, right?
Yes, you can. Okay. So, I mean, we haven't really done anything different yet, right? Conditions, we're just kind of doubling. Statistic changes a little bit, but I know where it is in the formula sheet. I know what to do. What's the next thing I put in? Put all your numbers. This is the decline of society. Someone asked me why. Someone literally said, "Why are there a bunch of hashtags?"
We don't play them either.
This isn't an AP class. This is not like, I don't know. It made me sad.
Wait, one of your students?
One of my AP students, yes.
We don't accept them.
It was you. No, it's you. What?
Well, it's believable enough. So
What?
like, did it happen?
I'm dumb, but I'm not
Yeah.
that dumb.
It was this year. I don't know what you said after. I don't know. I'm not gonna tell you.
Well, it has.
How do you know it wasn't a private conversation with someone in this class?
So it was in class the way you said
It
that.
was you. Maybe
Okay.
David's saying it's me.
And then the ends. We are blank percent confident. That the difference, and again, you're going to do the same order that you've done the whole time. Be careful about, here, let me finish this first, and then what the difference is between, whatever and whatever. I want to take a second and look at which ones have hats and which ones don't. Just make sure we understand why. So what does the hat mean? Came from the sample. Doesn't have a hat. And came from the population. So why does this one not have a hat? This is what I want to know about, right? I want to know about the population. These have hats because they're from the sample. So that's the data that I can look at. These have hats because it's the data from the samples. That's the data I can look at. And then this doesn't have a hat because, again, what am I trying to make the claim about? The population, right? So I want to claim something about the population. Here's me using my sample data, and then here's my claim about the population. No hats, no hats.
Somehow I never caught that.
So basically the inside two have hats and the outside one have no hats.
Yeah, I don't think I've ever said it that way.
Yeah,
Clearly
perfect,
before.
like,
That was helpful. That helped me. I feel smarter now. Any questions on this one? On the template? Alright, so let's do one. Go through how to do it in the calculator. And so this is I actually find the template like restrictive at this point because the conditions take so much frickin' space. The box is small. Like, to me, it's easier to use a sheet of paper, but you do you. All right, so this is the question. 22 out of 40 were college ready in 2017. So that was the year before you guys, 2018. Well, I guess everybody's different in here. Seniors got numbered. 95% confidence interval. So first thing you have to do with all these, because we're getting into like we're starting to have like 10 of these eventually. First question is it a test or an interval? We haven't done any tests, but it's an interval because we're trying to make an estimate. Is it means or proportions? Proportions, how do I know that? Because I'm dealing with like a fraction or a percentage. Proportion, that's all the same idea. And then do I have one sample, one set of data, or two sets of data? I have two. So then that is a 2 prop z interval. And you can go through each one of those words and like tell me why. So why is it 2? 2 sets of data. Why is it prop? Because proportions. Why is it z? Because it's proportions, same reason. And then interval because we're trying to make an estimate. We haven't learned the tests yet. We'll do that afterwards. Okay. So I'm going to say P1. Hat or no hat? No hat. This is the population. I'm trying to make a claim about it. P1 equals the true population proportion. College ready in 2017. But if you wanted to make your P1 2018, there's absolutely nothing wrong with that. P2 is the true population. Proportion. College ready in 2008. What's your problem, Shram? Oh, you're gonna need the entire semester then.
I already have.
This. Thank you.
That was hard.
Not your class, just the entirety of the semester.
Not your
Not like
class, everything but your class, of course.
Just,
Don't ever say like that to Mr. Slot.
Oh, not like just this class.
No,
Just
all the time.
everything.
Yeah.
Well, I can't really take responsibility for all of that. So, yeah. Okay, and then kind of my thesis statement, right? We want to estimate. This is a word a lot of people miss on the test. So we're just trying to make our best guess, whether it was a 1 or sample or 2 sample or whatever. So some people said that we want to find. We're not really finding. There's no way I can find out the population information. I'm just guessing at what it is based on what I know. So we want to estimate, not we want to find. The difference, and then you're going to choose which order you're doing it in. I'm going to do P1 minus P2. You don't have to. Everything would just be flipped for you if you did it the other way. At a 95% confidence level. That's like the first box. And again, those do not have hats on, right? Because that's population we're trying to make a claim about. We're trying to estimate something about the population. With the hats on? It's kind of fun. Alright, randomness. Problem states. All samples random. At least I think it did, didn't it? I meant to make it. Read through it. Nathan, you wrote it down, right? Like in painstaking detail? Okay. Independence. Now you got 3 things you got to do here. You got to say something about 2017 being independent, 2018 being independent, and them being independent from each other. So I'm going to say, assume each student in 2017 independent. Each student in 2018 independent. And each year independent. Does that make sense? The 3 things you have to show there? Like within A, within B, and between A and B. Alright, and then normality. Let's go back to the template for a second, because there is an option on this that I forgot to write down here. So instead of doing this NP and Q business, what else can we do there? Each what is more than 10? We have at least 10 successes and 10 failures. Right? So you can do that too if you want to write that on your template, so you could show at least 10 successes, failures for each. That's all this math is showing. Like if you figure out this math, it's going to tell you the number of successes. This will tell you the number of failures. This will tell you the number of successes. This will tell you the number of failures. Well, they just gave me numbers instead of proportions, so I could just kind of roll with what they did. So 2017 has how many successes? 22 successes. How many failures? 18 failures. 2018 has 17 successes. Alright, ready for this? How many failures? Nice job. He's prepared that whole time. And then I would just go, okay, those are bigger than or equal to 10. So this part is key. If you just write, there's the successes and failures, I'm going to why are you telling me that? Great. I'm wearing a blue shirt. Anything else you want to talk about? But if you now you're telling me greater than 10, okay, now it meets the condition. Like, that's the reason for it. Alternatively, if you really wanted to, you could do the NP, NQ for all. You have to do 4. Alright. Well, sometimes you have to. Alright. Statistic. Plus or minus. Critical value times standard deviation. Statistic. Your statistic is whatever you did up here, like that same order, except it's got hats, because it's from the sample. So I didn't even laugh until you made those. So my statistic is P1 minus P2. You did it backwards, or not backwards, it's just the other order. That's totally fine. Critical value, T star or Z star? Z star, because we're in proportions. And then the standard deviation, that P1, Q1 over N1, P2, Q2 over N2. Now this is, like when they give you the number of successes and failures, what don't I have? I don't have like P hat 1 and P hat 2, right? So I'm just going to go off to the side and go, okay, P hat 1 is 22 out of 40, because I need the decimal. You don't actually. So this is 0.55. All you need to do is put 0.55 in those spots. I'm just doing like my own little. You do not have to show this part over here in the box. I'm just doing it because it helps me. So this is 0.425. Because you're going to show that you know what P1 had is by putting it in. You guys with me? You see what I'm doing? Then find Z star. Same way you have before. That's 1.96. Good? Then you plug it into the formula, so 0.55, 0.45. Again, the ends don't have to be the same. So this is just you writing out pretending you're about to do the math, really. Like, here, I'm plugging in the numbers, I'm going to do some math. But you're not, you're just going to plug in your calculator. Now, some of you do the math, though, don't you? How many of you guys like actually do the plus minus part?
I sometimes control it. If I have time, I control it.
Like to check it. Yeah. That's the mood.
Or on the test, I actually forgot to plug the calculator.
So let's go through how to do the calculator. Because now the formula is longer, right? So the calculator becomes a little more appealing. So stat tests, 2 prop Z interval. Oh, you can't see that. It's like, so it's B. See where we're at? Maddie's not here, so we can go a little faster with the computer and the calculator. And then I'm just putting in, some of you guys didn't quite hold on to this concept all the way through the test. But X is the number of successes, and N is the sample size, and that's in your first sample. So this is going to be 22, 40, 17, 40. If you did it in my order, like you got to make sure you're doing the 1 and 2 the same way that you set them up. So for me, 2017 was first. 2018 was second. You gotta keep track of which way you did it. Or you're just putting in like the 2 fractions, basically. Not as fractions, but you know what I'm saying? Like 22 out of 40, 17 out of 40. We good? And hit enter. That gives you all the stuff. So it actually tells you P1 hat, P2 hat. So you could run through this first, and then, like, before you wrote this stuff, then you wouldn't have to worry about doing this stuff over here on the side. Everybody get what I got? Negative 0.0923. Okay, so negative 0.0923. 0.34234. We are 95% confident. P1 minus P2, again, keep it in your order. And now it doesn't have hats because we're trying to make an assumption about the population. Is between negative 0.0923 and 0.3423. Everybody do it backwards. Not backwards, it's not wrong. Just everybody do the opposite of what I did. If you had, you would get negative 0.34234 to positive 0.0923. It would just flip the sides of both, and that's fine. 7 minus 5 is 2, 5 minus 7 is negative 2. They're both true, they're both fine. One thing in this one, so they love to ask you this question. If I claimed that these two proportions were different, would you reject that claim? This gets into like a whole thing we haven't talked about, but we're going to try it. My claim to you is these two proportions are different. Let's just do it this way. What do you think of that claim? Be careful.
This is 22 and 40 and 17.
The true population proportions. So I just have this small picture of these two populations. From that, I'm 95% confident that the difference in the true populations, like the big picture, is between these two numbers. Are you confident enough to say that these two proportions are different? Or do you think you probably shouldn't say that? Yeah. You got it.
I don't think you can because you got a 95% confidence interval and zeros in the interval.
That's the thing. So if they're really the same, what's the difference between them? If they're actually the same proportion, what's the difference between them when you subtract? 0. Is 0 in that interval? Is 0 in this interval? So there's a 0 in there. We went around 0. There's a 0 in right like in the middle. So I can't really say they're different because there's a 95% chance the true difference is in the middle here, and 0 is in the middle. So because 0 is captured in there, I can't be confident enough to say, like, yeah, those two are different. I can't say they're the same either, but I can't say they're different. If this was like, if we did this and we got like 1 to 5, that doesn't make any sense. It'd be like 0.08 to 0.17, let's say. Now, I'm 95% confident that the difference between these two proportions is somewhere in the middle there. Well, anywhere in there, there's an actual difference, right? Because 0's not in that interval. That's a really common question they ask. We'll practice it a ton more. But does that make sense or not really? Okay. Any questions on this one? It's the same stuff, right? We basically just made it more annoying. That's kind of all that. Yeah. Yeah.
For independence, could you do the?
You could do
10%
for this and this.
Yeah.
For the like A and B, but then for the difference. For the independence between them, but there's not going to work. Yeah, just gonna say it. All right, that's it. That's all I want. You have Con due Wednesday. It's on 2 things. We just learned one of them, so if you want to start it, you could.